Hello, welcome sa channel. Ang topic natin ngayon is all about DC circuits superposition theorem. So ito, it states that a circuit with multiple voltage source and current source is equal to the sum of simplified circuits using just one of the sources. So ibig sabihin, ang total current is the sum of simplified circuit. So using of the other sources and then one sources lang yung papaganahin and then vice versa. So we have this example. So we have 200 volts on the left, on the right side is 100 volts. So isolve natin siya using superposition theorem. But bago natin siya isolve, let's solve for the total current IE, IB, IC using mesh method. Using this method, I have alternate method. I call this hard circuit method. So this hard IA ito, and then this is hard of IB, and then this is hard of IC. So ang gagawin natin is this is the fastest technique. And then for IE, so what's inside for the law of IE? So we have 100 plus 400. So this is 500 for IB. So this is negative 400 for IC. This is 0 is equals to negative 100 transposed to the other side. So this is 200 volts. For IB, so the resistors inside are 200 plus 400 plus 500. So this is 2 plus 4, 6 plus 500 is equals to, we have 1100. For IE, this is negative 400. For IC, this is negative 500. This is equals to 0. And then for hard IC, this is 300 plus 500. So this is 800. And then for IB, this is negative 500. For IE, this is 0. And then this is equals to rotate positive 100. So this is equals to, this is negative 100. And then using the calculator, I have it online. So C. Using calculator, so we have three equations, three unknowns. Equation 1 is 500, negative 400, 0, and then 200. Equation 2 is negative 400, 1, 1, and then negative 500, 0. Equation 3 is 0, negative 500, 800, and then negative 100. Okay, and then we have the values. For IA is 0.567 ampere, for IB 2.09, then IC is 5 milliampere. So madali lang siya. And then this is now our total current using hard circuit method. So di pa natin siya ginagamitan ng superposition theorem. So ngayon gagamit na natin siya. And then this is now our superposition circuit number 1 on the other side, and then off the other side, itong sa kanan. And then I assume that on all of 1, meron siya IE prime, IB prime, and IC prime. Okay, using hard method again. So for IE prime, so the resistor inside is 100 plus 400. So we have 500. And then for IB, so this is negative 400. IC is 0. This is equals to negative 200. So this is 200. For IB, we have 400 plus 200 plus 500. So this is 1, 1. For IE, this is negative 400. For IC, this is negative 500. And then this is equals to 0 because wala siyang supply. And then for IC, we have 300 plus 500. This is 800. and then for IB, this is negative 500, and then for IA, this is 0, this is equals to 0. As you can observe, wala na siyang supply. So, na-off na siya. And then using calculator again, the equations to anon, 3 equations, 3 anon. We have, using the 3 equations, 3 unknowns calculator. So, equation 1, 500, negative 400, 0, 200. Equation 2, we have negative 400, 1, 1, negative 500, and 0. For equation 3, we have 0, negative 500, 800, and 0. So, enter. Okay, so, sir, meron ka na answer. We have the answer. IE prime is 0.673 ampere. For IB, 0.342 ampere. For IC prime, this is equals to 0.213 ampere. So this is now for the superposition circuit 1. Turn off one sources, turn on other sources. So next is ganun again, turn off other sources and turn on other. So vice versa. Okay, let's continue. Using the second superposition circuit, so turn off the other left side, turn on the right side. So ganun again, using the hard circuit method. So on this loop, IE double prime, so 100 plus 400, so we have 500. And then for loop current for IB, so this is negative 400. So IC is malayo siya, 0. And then there is no supply, so this is automatic 0. Then for IB is we have 500 plus 200, 7 plus 5, 6, this is 1, 1. Then for the IE, so this is negative 400. For IC, this is negative 500. Then this is equals to 0. Then for IC prime, so 5 plus 3 is 8. So this is 800. And then this is negative 500. And this is 0. This is equals to. Then it have one source. So negative positive 100. So transpose to other side, so this is negative 100. Okay, using calculator again, 3 equations, 3 unknowns. So we have, using calculator, 3 equations, 3 unknowns. So for equation 1, we have 500, negative 400, 0, and then 0. Equation 2, we have negative 400, 1, 1, negative 500, and 0. For equation 3, we have 0, negative 500, 800, and negative 100. So we can arrive the answer. For IE double prime, this is negative 0.106 ampere. For IB is negative 0.133 ampere. For IC is negative 0.208 ampere. So we have the value for superposition circuit number 2. And then let's add the total current for the on and off supply. So for IE, so we have is equals to 1E prime plus IE double prime. For IB is IB prime plus IB double prime. For IC, IC prime plus IC double prime. So for IE, we have, this is 0.673. This is minus plus negative 1.106 ampere. So the answer is 0.567 ampere. For IB, we have 0.342 plus negative 0.133. This is equals to 0.209 ampere. For IC prime, we have 0.213 plus negative 0.208. So this is equals to 0.005, so automatically 5 milliampere. As you can observe that this IE prime on this side is the same as on this value, and then for this IV, this is the same for this superposition theorem, IV prime plus IV double prime. And for IC, 5 milliampere, so this is the same. So okay, we will have a review. So again, for this calculation number 1, this is the total current. There's no superposition apply, so directly hard circuit method or mesh analysis. And then for this circuit number 2, on the left side, and then off the right side, and then we can arrive the current IE prime, IB prime plus IC prime. So, then for circuit number 3, so reverse, off the left side and then on the right side, and then we can arrive the current IE prime, IB prime, IE double prime, IB double prime, IC double prime, and then adding all the values, so on this formula or pattern, then we can arrive the same answer. So that's all for superposition theorem. So hope you understand the topic. So thank you.